Hi children, we continue with our third chapter, synthetic fibers and plastics. In the last classes, we discussed about the various types of synthetic fibers and their uses, properties, etc. Now we move on to the second half of the chapter, that is plastics. So plastics. Just like synthetic fibers, plastics are also polymers. So, just like synthetic fibers, plastics are also polymers. What is a polymer? Polymer is a large single unit which is formed by the repeated addition of many small units known as monomers. Okay, a large unit formed of many repeating small units called monomers. And all plastics, they do not have the same type of arrangement of monomer units. The arrangement of monomer units in different types of plastics is different. So it can be, the arrangement of monomers can be either linear or cross-linked. In plastics, the monomers can be arranged in a linear manner or in a cross-linked manner. Now I will show you how the linear arrangement looks like. So here, this is how the linear arrangement looks like. Each of these squares represent monomer. These squares represent the monomer units. Squares represent the monomer units. So all the monomers are arranged in a straight line manner. That is known as linear arrangement. All the monomers are arranged in a straight line pattern. That is known as a linear arrangement. And don't forget to show these lines on both the sides. These are extended lines. So as I told you, polymers are made up of many repeating units of monomers. Here I have shown you only 4 monomers. But the number is not limited to 4. There can be large number of monomer units. The number of monomer units is not just 4. It can be more than 4. So you have to show these lines on both the sides, which shows that the chain extends to both the sides. There are more monomer units which can come and attach on either side of this chain. Okay. So don't forget to show these lines on either side of the chain. Okay. Now I will show you how the cross-linked arrangement looks like. In cross-linked, this is how the cross-linked arrangement, a cross-linked pattern. It is not a straight line, but it is cross-linked. Here, don't forget to show the lines, extended lines on all the monomer units. What does it indicate? It indicates that the chain can be extended on all these sides. All these lines show, these are actually points where monomers can come and attach. The number of monomer units is very large, but in a diagram we cannot show a large number of monomer units. That's why we show it like an extended chain. So this is cross-linked arrangement and this is linear arrangement. This is very important, drawing the two types of arrangement of monomer units in plastics. Okay, so what are plastics? Plastics are also polymers. A polymer is nothing but a large single unit which is formed by the repeated addition of many small units known as monomers. And all different types of plastics, they have different types of arrangement of monomer units. The arrangement can be either linear. Linear means all the monomers are arranged in a straight line fashion, or it can be cross-linked, where the monomer units are cross-linked and kept. But in both the arrangements, you have to show lines on, in the linear arrangement, lines on either side of the chain only. But here, everywhere, all the monomer units, you have to show the line. Okay. So linear arrangement and cross-linked arrangement. Now examples for plastics we will see. Examples for plastics. First one is a very familiar plastic, polythene. You all are familiar with polythene, the plastic known as polythene, which is widely used for making the carry bags, polythene carry bags, which we take for shopping, isn't it? So actually it is actually poly plus ethene. So what is the monomer here? What is the monomer unit in polythene? It is ethene. Polyethene. Many ethene molecules. Here the chemical substance or the monomer units are ethene molecules. Okay, so many ethene molecules add together. Poly means many. Many ethene molecules add together and you get a polymer known as polythene. Where is it used? For the manufacture of polythene bags, carry bags. Now the second one, this is also familiar to you, PVC. Have you heard of PVC? Yes, PVC is used for making pipes, PVC pipes. Widely used plastic for making pipes. And the full form is polyvinyl. The full form of PVC is polyvinyl chloride, PVC. So poly means many. Vinyl chloride is a chemical substance. Vinyl chloride is a chemical substance. All these you will learn in higher classes. So many vinyl chloride units add together and you get a big unit known as polyvinyl chloride or simply polythene, PVC. Okay, and PVC is widely used for making pipes. So these are the two familiar examples of plastics: polythene, polyethene. Many ethene molecules add and you get a polymer known as polythene, and it is used for making carry bags, polythene bags. And the second one is PVC, polyvinyl chloride, PVC. Many vinyl chloride units add and you get PVC. Now it is used for making pipes. So these are the examples. Now types of, next topic is types of plastics. We have to learn about the two different types of plastics. The first one is thermoplastics. Thermoplastics. Thermal energy means heat energy. So it has some connection with heat energy. And the definition of thermoplastics is plastics which can be deformed on heating, change its shape, deformed on heating and bend easily. Plastics which can be deformed on heating and can be bent easily are known as thermoplastics. And here the arrangement of monomer units is linear. In thermoplastics, the monomer units are arranged in a linear manner. So these are the two important points that you have to remember under thermoplastics. The plastics which can be deformed on heating and can be bent easily are known as thermoplastics. And here in thermoplastics, the monomer units are arranged in a linear manner. Now, the easiest way to explain thermoplastic is, thermoplastics, just for you to remember, thermoplastics are plastics which when heated become soft. Plastic when it is heated it becomes soft. Then again when you cool it, it becomes hard again. And again you heat it, it becomes soft, cool, it becomes hard. This process can be repeated any number of, same process can be repeated any number of times. So such plastics are known as thermoplastics. Upon heating it becomes soft, when you cool it, it becomes hard. Again you heat it soft, then cool, hard, and this process can be repeated any number of times. So upon heating, deformation takes place. It changes its shape on heating and this process continues. Any number of times you can repeat the same process. Such plastics are known as thermoplastics, and here the monomers are arranged in a linear manner. Examples of thermoplastics are polythene and PVC. So important thing, the two different types of plastics. First one is thermoplastic. The plastics which can be deformed on heating and can be bent easily are known as thermoplastics. plastics. Actually, the thing you have to understand is upon heating becomes soft. Then again on cooling it becomes hard. Then heating soft, cooling hard, and this process can be repeated any number of times. So, upon heating you can change its shape and you can mold it into any other desired shape. Examples are polythene and PVC. Now, the second type of plastics. Thermosetting plastics. Here, these are plastics which when molded once. What do you mean by molded? Made into a particular shape. Molding means making into a particular shape. Once it is molded into a particular shape, plastics which when molded once cannot be softened on heating. It is just the opposite of thermoplastics. This type of plastics, once molded into a particular shape, once made into a particular shape, heating doesn't produce any change on it. They cannot be softened again on heating. Or we can say this thermosetting plastics upon heating, they become soft. You cool it, it becomes hard. After that, you heat, no change. In a thermoplastic, it is not like this. Any number of times you can make it soft, hard, again soft, hard, like that you can go on. Here, once it is softened, made into a particular shape, once it hardens, heating doesn't bring any change in its shape. So, such plastics are known as thermosetting plastics, and here the arrangement of monomer units is cross-linked. Okay, cross-linked arrangement of monomer units. So, what are thermosetting plastics? The plastics which when molded once cannot be softened on heating are known as thermosetting plastics. Once it is heated and once it is set into a particular shape, no change on heating. No more softening on heating. So, that is thermosetting. Once it is heated and cooled, it is set forever. Okay. So, the arrangement of monomer units is cross-linked. Examples. First one is, two examples you have to learn. First one is Bakelite. Bakelite is the plastic which is used for making electrical switches. Then handles of utensils. It is used for making electrical switches and also handles of many utensils like screwdrivers. The handles of screwdrivers are made up of the plastic Bakelite. Here it is a poor conductor of heat and electricity. Bakelite is a poor conductor of heat and electricity. It is used for making electrical switches and also handles of various utensils, especially screwdrivers. That's an important question. Why the screwdriver handles are made up of thermosetting plastics? Because it is a poor conductor of electricity. Okay. Now the second one is, so switches, electrical switches and switchboards are made up of thermosetting plastic known as Bakelite. The plastic which is used for making electrical switches is Bakelite. Now the second example is Melamine. Melamine is used for making floor tiles, cookware and also fireproof clothes. So, this melamine resists fire. Melamine resists fire and tolerate heat. It can tolerate heat better than other plastics. So, melamine resists fire and also it can tolerate heat better than other plastics. It is used for making floor tiles, cookware. Melamine cookwares are there, cups, saucers, plates and all, which can withstand very high temperature, and also fireproof clothes. The uniforms of firemen have a plastic coating that is made up of this plastic, melamine. Uniforms of firemen have a melamine coating. Give reason. This is a question. What answer you will write? Because melamine resist fire and it tolerates heat better than other plastics. That's why it is used for making fireproof clothes. Uniforms of firemen have a coating of melamine. Okay, so these two are the examples of thermosetting plastics, bakelite and melamine. So what are thermosetting plastics? Plastics which when molded once cannot be softened on heating are known as thermosetting plastics. Here the arrangement of monomer units is cross-linked. Examples are bakelite and melamine. Bakelite is the plastic which is used for making electrical switches and handles of many utensils. It is a poor conductor of heat and electricity. Melamine, another plastic, another thermosetting plastic which resists fire and tolerate heat better than other plastic. It is used for making floor tiles, cookware, kitchenware and also fireproof, to make fireproof clothes like uniforms of firemen. Okay, so that's all. Thank you children.